about the graph of a cubic function, okay? So a cubic function is a third degree polynomial, and it's got a couple of very distinct forms. We've spoken already about how our cubic function is of degree 3, so the power there, the maximum power 3. Now, a positive cubic, okay, has the shape that we've got down here on the left. So it's almost like two separate parabolas in terms of shape, okay, except they don't stop and come round, they continue up, all right? That point there, okay, is what we call a point of inflection. Whereas a turning point comes up and then comes down, okay, a point of inflection comes up and then continues on, all right? So it's increasing the whole way. So my cubic graph in the form of just y equals x cubed has a point of inflection. It starts a positive cubic, okay, as x gets bigger, the graph gets bigger. So it finishes up here in the top right corner. My negative cubic is if the a term is less than 0. You can see here, say negative a half x cubed. Okay, again, point of inflection. It starts from the bottom, top left, and as x gets bigger, it goes down into a negative direction. So they're the key things. My domain for my cubic function is R. The range for my cubic function is R. Okay, so they're obviously 2 points or 2 terms that we've had quite a bit to do with. So let's think about the general form of my cubic. Again, if we think about what my parabola does, okay, we know in here, left and right, and we know the +1 is up and down. And it's exactly the same here. The number out the front, dilation, makes it wider and skinnier. The K, a plus K, translates the graph up, okay? If it's a negative K, obviously it moves it down. That point of inflection that we talk about here at the origin, well, that moves up K units. X minus H all cubed, okay? So inside the bracket, it moves it left and right, okay? So the point of inflection moves left and right. So what really that leads us to is this general form, a bit like my turning point, okay? So if my graph A x minus H all cubed plus K, so my H shifts it left and right, my K moves it up and down, so my point of inflection becomes at the point HK, all right? So if we just look at the little graph we've got here, it's the only one. So we know the general shape, identify in your head the general shape. So it's a positive cubic, so it looks a little bit like that. And if you have to, draw half a parabola and draw another half of a parabola and join them together. So it's 2 across and 4 up. So my point of inflection goes 1 across to 2, up to 4. And so my basic shape, it goes across and then continues up, yeah? To find my intercepts, okay, I do exactly what I've done in the past. To find my y-intercept, I just put x equal to 0. So y-intercept, x is equal to 0. It doesn't matter what kind of graph I'm dealing with, does it? So if I put x equal to 0, y is equal to 0 minus 2 all cubed plus 4. So y is equal to negative 8 plus 4. So the y-intercept is equal to negative 4. So we can see straight away there, my graph has to change a little, doesn't it? Okay. So negative 4. So my intercept is at 0, negative 4. Let's get my x-intercept. I'll put y equal to 0. So I get 0 is equal to x minus 2 all cubed plus 4. Take the 4 across. Now, when we're dealing with square of a number, we can't get the square root of a negative number, but I can get the cube root of a negative number, okay? Because don't forget the cube root of negative 8 is just negative 2 times negative 2 times negative 2, right? Is equal to x minus 2. And so if I take the 2 across, x is equal to 2 plus the cube root of -4. So this number here is a little bit less than -1, probably, well, between -1 and -2. So it's a little bit less than 2. So there's my intercept. So in actual fact, my graph, if I take away the original graph that I drew, let's take away that, my point of inflection doesn't change. It's still the 0.24, but through there to there. So it's a little bit ugly, isn't it? So it's a little bit tight to draw. That's probably a little bit better like that. All right. So it's a nice steep curve to start with and goes up. So the key points, we label them. So we'll just call it 2 plus cube root -4, 0. And that point there, we'll call that the point 0, -4. Okay, so I guess a better shape would be a really steep, something like that. Okay, put it into your CAS if you want to have a clearer look of what the picture is. All right, let's go to the next of the X terms is 1. So exactly the same principle. All right, so identify the shifts that are taking place. So again, I've gone across 1 unit, I've gone up 2 units. So my point of inflection at -1, I wonder if I can get away with calling that -1. Just the scale's a bit tight. So what if we call that -1, -2? So that would be +2. Okay, so we'll call that the point -1, 2. Let's find our y-intercept. So before I sketch it this time, I'll get my y-intercepts and x-intercepts. Y-intercept, x equal to 0, y is equal to 0 plus 1 cubed plus 2, which is equal to 3. So I get the point 0, 3. So we're going to call that 2, so we'll call 3 about halfway up. And my x-intercept, I'll put y equal to 0. 0 is equal to x plus 1 cubed plus 2. -2 is equal to x plus 1 cubed. We'll take a cube root of -2 is equal to x plus 1. Notice we don't do the plus or minus. So -1 minus plus the cube root of -2 is equal to x. So that's going to be -1 minus a little bit more. So my intercept might be, I don't know, there's -1, so we'll call it there, say. So the graph this time up fairly steep to that point of inflection and then continue up fairly steep. Okay. What do we notice about this third one? I've got a negative graph here, so it's going to go this way. All right. What's my graph doing? It's going across 1 unit, down 2 units. So we'll go across 1, we'll call that 1 there, down 2, so we'll call that there at the point -1, -2. And we just get our intercepts again. Y-intercept, we'll put x equal to 0. If x is equal to 0, y is equal to -0 minus 1 cubed minus 2. Y is equal to -1 minus 2. 1 minus 2, which equals -1. So the intercept is at 0, -1, which we'll call that point there. And let's go with my x-intercept. I put y equal to 0. That's a very familiar statement, isn't it? So 0 is equal to -x minus 1 all cubed minus 2. I might take that whole x minus 1 term to the left-hand side. Again, we'll get a cube root, so x minus 1 is equal to the cube root of -2. So x is equal to 1 plus the cube root of -2. So it's going to be 1 minus a little bit. So hang on, let's think about that again. So the cube root of -2 is going to be bigger than 1, isn't it? Because -1 times -1 times -1 is just -1. So we're going to have a value, just a small negative number. So I don't know, a small negative number might be there. So my graph this time is going to come down through the x-intercept, through the y-intercept to my point of inflection, and then continue down. Okay? Sorry, boys, a bit distracted. I'm watching the IPL. So there's my basic shape for my y equals x cubed graphs. Okay, shifting left and right, up and down. Negative sign, different areas it starts with. All right, so let's practice those.